Okay, welcome to video 5.5. Here we're going to be talking about application system word problems, solving them graphically. So, similar to what we were just doing, only now we're going to use graphs. Let's look at this first example. Next weekend, Maggie wants to rent a car. Enterprise charges 25 cents per mile, and they also have a down payment of $60, and Hertz charges $1 per mile for unlimited miles, but they don't have any down payment. So we need to write the two functions, e of x and h of x. So they told us we had to use e of x and h of x, so that means that we need to put those as y equals. To model the situation described above, where x is used to represent the number of miles driven. So if we look back at the examples, let's start with Enterprise. The first one said that it was 25 cents per mile, and we also have a down payment of $60. So to write that equation, we're going to start with e of x because they told us we had to use function notation and had to use e of x, equals, and then we're going to charge 0.25 or 0.25 per mile x, and the $60 fee. So e of x equals 0.25x plus 60. Okay, that's my first one. My second one is then that h of x equals, and that's 1 per mile, 1x, and there's no start fee or anything, so that's it for h of x. Okay, so those are my two equations and function notation. Now it says to use the grid to sketch each function, so I'm just going to move this down so I can see that. So first, to start off, we're going to put a table, so I'm just going to put car rental as the title, and we're going to have two tables because we have two equations, so I'm just going to write x in the one column and then e of x in the y column, since that's the y values. So remember, we can get the table by going to y equals in our calculator, putting in the equation, so starting with 0.25x plus 60, going to second graph so that shows us the table of values, and then I just wrote down some, and I spread them out because we need to show up to 100 miles, and the cost is going up to 120, so I didn't want just like a small sampling, so I just spread them all out, so I have some nice points to plot. And the same thing for the h of x, just plug in 1x, and then you get your table of values the same way. Second graph to get the table, and then we can go ahead and plot these points. So I'm going to start with the e of x, start by plotting those points. So start by plotting those nice points, and then we need a straight edge so we can connect, and since it's an equation, we don't have to worry about line type or anything like that, so just connect them and put an arrow going right forever, because we can go positive forever. However, we cannot move to the left forever, so no arrow into the negatives. And then be sure to use a label, and it can be as simple as e of x for this one since it's in function notation. E of x is enough to say that that's different, but if you want to, you can also write the entire equation. Then do the same thing with h of x. We just need to graph that equation, so start with the points at 0, 0, and then plot all those points. Once you have the points plotted, then again connect with a straight edge. And then again, in this case, we can put an arrow on the one side because we can go up forever, although we cannot go into the negatives, so we do not put an arrow on the other side, so no arrows into negatives. Okay, and then we need to put a label on the end here to say that this is h of x, and you could write the whole equation if you want, equals 1x, or just label them h of x and f of x. Because they were in function notation, this is fine rather than saying y equals. I can't label them both as y equals, that wouldn't make sense. But e of x and h of x, that separates the two functions. So the only difference here between what we've been doing in the past and what we're doing now is rather than having one equation graphed from an equation, from a word problem, we now have two different equations that go on the same graph. So now it's a system, but other than that, everything else is very similar to what we've done in the past. Okay, let's do the follow-up questions. Okay, so using mileage, which company should Maggie choose and when? So this is specific to the situation. If we can see on the graph here, when we're traveling miles between 0 and up to this point where they intersect, anywhere over here, this blue line is the total cost is lower. So I'm going to say that this is the better company. So that means that the h of x, that function, that's the better company when we have between 0 and 80 miles. And at 80 miles, it doesn't really matter. And then anywhere above that, well, then the purple line is lower, so it has a little lower total cost. So then I just wrote, Enterprise is the better company when traveling less than 80 miles because the total cost is lower, and Hertz is a better company when traveling more than 80 miles because the total cost is lower. At 80 miles, either company can be used because the cost is the same. Okay, we'll do the rest tomorrow. Have a good night.